So let's take a look at a couple of examples here. Sketch the graph of f, then identify the value or values of a for which the limit as x approaches a of f of x exists. So we're going to try and figure out if there are any values where this limit doesn't exist for this function. So we have this piecewise function, so we're going to graph this. Easiest way is just to graph piece by piece. So let's take a look at this first piece saying that if x is less than or equal to 2, then the function looks like x squared. So x squared would have the point 1, 1, it would have the point 0, 0, it would have the point negative 1, negative 1, and then negative 2, 1, 2, 3, 4. So about there, and 2, 4. So I'm going to include only the portion that's less than or equal to 2. So it would come down like this, come up, and then stop right here at 2, 4, because it's only that portion of the function is only defined for x less than or equal to 2. Okay, and then from 2 to 4, but not including any of the endpoints, either of the endpoints, it's 8 minus 2x. So 8 minus 2x, when x is 2, would be 8 minus 4 or 4. So it'd actually be at this same point right here. And when x is 4, that would be 8 minus 8, that would be 0. So when x is 4, I'm actually not at 0, but I have an open circle there, and I just have the line connecting that. Okay, so like that. All right, and then when x is greater than or equal to 4, I'm stuck at the value 4. So when x is 4, I'm at the value 4, and then it's always 4 forever, and it was always going backwards there from that. So that's the graph of this function. Okay, so what we're asking is what values of a, if we look at all the x values, is there any x value, or are there x values where the limit wouldn't exist? So in other words, is there a place where if you approached from the right and the left, you either don't get values from the individual side limits, or you get values from the side limits, but they don't agree? Okay, so let's take a look. So basically, I think that any point in the negatives, you have all these places where the limit is perfectly fine. If I just took some, say, negative 2 here, if I approach from the left and from the right, I'm really headed, well, it's actually more up here. So if I approach from the left and from the right, I'm headed to 4. And so all these places look fine. There's only really 2 places that I have some concerns, at 2 and at 4. Now, let's look at 2. As I approach 2 from the left, I head to the value 4. And as I approach 2 from the right, I head to the value 4. So the limit is fine. The limit as x approaches 2 of f of x is in fact 4. So we're okay. It does exist. Now it doesn't approach in exactly the same way. It comes up on the parabola on the left and on a straight line on the right, but it does head to the same point. But what about 4? Okay, as we approach 4 from the right, we get the value 4. But as we approach from the left, we head to the value 0. So what we've seen is that the limit as x approaches 4 from the right of f of x is 4, but the limit as x approaches 4 from the left of f of x is 0, and these do not agree. So the limit as x approaches 4 of f of x does not exist. All right. Now, what I can say, since I'll answer the question as it was asked, the limit as x approaches a of f of x exists for all real numbers except x equals 4. So x equals 4 is actually the only place where the limit does not exist. All right, a good way to see if you're understanding what's going around is reverse the problem. Now we're going to sketch a function, the graph of a function, not give it analytically, just sketch a function that has these 4 properties. F of 0 is undefined. The limit as x approaches 0 of f of x is 4. F of 2 is 6. And the limit as x approaches 2 of f of x is 3. So there's infinitely many answers to this. We just need to incorporate those 4 pieces. Okay, so let's see how we could do this. Let me set up some axes here. All right, and I'm going to say just markings 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so it says f of 0 is undefined. All right, not a lot I can do with that initially because I can't really show f of 0 being undefined. But the second one here says limit as x approaches 0 of f of x is 4. So we're around 4 when we approach 0, meaning, but it's undefined. That's why I put it as open, because I couldn't put a point at x equals 0. So it says, so from both sides, left and right sides, I'm supposed to approach 4. Now I can do that in any way I want. I might, come straight at it, from the left, but maybe I'm curving towards it from the right. I'm just making this up. All right. So I've actually now shown both of these first 2 things. I've got f of 0 undefined because of the hole there, and I've got the limit from the left and the right equaling 4. So now let's look to the next thing. F of 2 is 6. All right. Well, there's x of 2. 1, 2, 3, 4, 5, 6. So there's 2, 6. If it's saying f of 2 is 6, that means that the point 2, 6 has to be on the curve, on the graph. But while that's true, it says the limit as x approaches 2 of f of x is 3. So as I'm getting closer to x equals 2, I'm supposed to be heading towards 3. So I think what I could do is I could put a hole at 2, 3, and then just approach it from the left and say approach it from the right. So now I have the limit going to 3, but the actual value is at 6. So this is one possible answer here. As long as I have basically something that looks like this going on at 0 and something like this going on at 2, all the rest could be whatever. All right, I could have done anything before in this region here, in between here, and after 2 over there. And I could do whatever I want there as long as I have those main points here that captured all of these. Okay.